Alright, so now it's time to talk about the distribution of Earth's water, which is very unequally distributed. Alright, so take a look at this chart, and anytime you look at the distribution of Earth's water, you'll find a chart that looks like this. The numbers fluctuate a little bit, but this is a nice one that simplifies things for us so that we can evaluate this. Starting over here at the first step, you can take a look at Earth's water, and if you take 100% of Earth's water, it shouldn't surprise you that most of the Earth's water is in the oceans. Right, 97%. The Earth's oceans take up about 71% of Earth's surface. All right, and salt water, being water that's infused with minerals and ions, that basically come from the collective erosion of land surfaces around the planet. So land is constantly being eroded, and creeks and streams and rivers are dumping those dissolved minerals into the world's oceans, and that's why salt water is what it is. All right, that's unusable for drinking, for cleaning. At this point, desalination plants exist, but they're very costly, and it's economically unavailable at this point. So that leaves 3% of the Earth's water as fresh water for us to use. But if you look at the next step here, most of that is locked up in ice caps and glaciers. Now, ice caps and glaciers, due to climate change, are decreasing. Now, that's important for two reasons. That's important because when ice caps and glaciers melt, that water goes into the ocean. So we're losing fresh water on Earth, and it becomes unusable. But also because many glaciers on Earth are used by people for a water source. Hundreds of millions of people around the world use glaciers for their source of water. So as those glaciers melt and climate change continues, a source of water for millions and millions and millions of people is lost. An example of that is, in fact, the Colorado River. Much of the water of the Colorado River is fed at the headwaters by snowmelt in the Rocky Mountains. So as climate changes, that snow isn't being replenished as it used to be, and that source of water is decreasing. Alright, so glaciers and ice caps represent about 68% of our world's freshwater. 30% of our world's freshwater is in groundwater, and then that leaves just a small little fraction on the surface for us to use and enjoy. Of that surface water, if you look here to step 3, most of our surface water is in the form of lakes. About 11% is in swamps, and 2% is in rivers. So of the fresh water that is on the surface, most of it's in lakes. Alright, so let's go through this a little bit and talk about some of the concerns we have when it comes to water and how it's distributed on Earth. So let's start here with glaciers and ice caps. If you look at the chart here on the top, what we're looking at is a 30-year period for this glacier and its mass balance, or the net gain or loss. So this particular glacier, we're losing ice over time, and what we have here is a 14-meter loss over a 30-year time in this particular glacier. And that's what we see for most glaciers around the planet. We're seeing a retreat or a net loss of ice for these glaciers. We're losing our world's glaciers as we speak. And if you look at the picture on the bottom, this is what this glacier looked like in 1913, and only 90 years later it's virtually gone. Glaciers in the lower latitudes are obviously being lost a little bit faster than glaciers at high latitudes, but nowhere is safe. We're seeing glacial ice deteriorating on the planet. And here you go, here's another picture of a glacier. And if you look here, the glacier is actually flowing in this direction. Right, there's a large body of water at the top here where the glacier is flowing into. And this is time 1, this is time 2, and if we look at time 3, from time 1 to time 3, you see a lot of this glacier just breaking up farther and farther back up the mountain. And you see these big chunks just breaking off and being lost into the water. So this is the amount of ice that was lost from time 1 to time 3, which is significant. Continuing with ice sheets, a little bit different than glaciers. Greenland is an example of an ice sheet, and here's Greenland here in this picture of the Earth. You see the upper latitudes where the extent of ice goes into northern Canada. But let's take a look at this ice sheet. What we're seeing is, as melting continues, what's happening is shipping lanes are opening up in these high latitudes, and you're seeing ships use these northern passages. Never before has the Northwest Passage been opened, but we're seeing it opened now. So what happens is there's more and more traffic in those areas. It's becoming more and more accessible. As that traffic continues, you see the soot and the debris that lands on the surface of the ice up in these northern latitudes. Now what happens is, as that dirt and dust and soot, as that deposits on the surface of the ice, it turns black. So now, when sunlight comes in, ice is has a very high reflective property called albedo, but pure ice will reflect the light. But now that the black surface is there, the light is actually going to be absorbed, and the ice is going to melt that much faster. So increased traffic in these northern latitudes is actually accelerating the melting of the ice, and we're seeing that more and more every year. Alright, which brings up a concept here that you're going to want to get a note on. Concept is called albedo. Very simple concept. It's literally the reflectivity of a surface. Pretty easy concept, but thinking about it in the water cycle here, take sea ice, and when you see these percentages, that means the reflectivity. So sea ice has a reflectivity of 90%. It reflects 90% of the incoming light. Whereas water reflects, let's say at its highest amount, 60%. So where incoming solar energy would have been reflected, now you have 30% less energy being reflected after an ice melt. So if there's more water on Earth, there's going to be more energy absorbed by Earth, less reflected. What's going to happen to temperature on Earth? It's going to rise. What's going to happen to sea ice? It's going to melt. So you're going to have more absorption of energy and more temperature rise. So we need ice on the planet to do that reflecting because it moderates temperature and climate. Here's some other examples of albedo. A forest reflects 20% of the energy. All right, it absorbs 80%. All right, snow has a high reflectivity, whereas asphalt has a low reflectivity. It doesn't reflect that much light at all, and that should make sense to you if you've ever walked into your driveway on a hot sunny day with bare feet. The asphalt is absorbing most of that energy, which leaves it hard to walk on. It's just too hot. So albedo is a pretty simple concept, and you're going to want to keep that in the back of your mind as we move through this lecture and then also through climate. So just to give you a sense of the amount of water in an ice sheet, Greenland is the world's biggest ice sheet in the northern hemisphere. Antarctica would be the largest one in the southern hemisphere. How much ice sits on Greenland? If you melted it, it would fill the United States up to 2,940 feet. All right, it would basically submerge all of North America. So that is a lot of water, is the point, locked up in ice in Greenland alone, which is melting. So we need to keep an eye on that. All right, moving right along. Of the freshwater on Earth, 3% of Earth's water being freshwater, about 70% of that is locked in glaciers, and then you have another 30% locked up in groundwater. An example of a groundwater supply would be the Ogallala Aquifer, and I'll introduce that now. We'll be talking about this. An aquifer is an underground water supply, and the largest one in the United States is the Ogallala Aquifer. All right. In the center of the country is this groundwater supply, which feeds most of the country's breadbasket. Most of our agricultural land is fed by the Ogallala Aquifer. What we're doing is we're overusing that resource for agriculture, for municipal uses, for recreation, for whatever. We're overusing that resource and we're depleting this groundwater supply. Alright, and then a portion of our freshwater on Earth is found on the surface. The largest surface feature of freshwater are the world's lakes. And if you take a look here, I'm giving you the largest lakes in the world, the Caspian Sea being the largest lake in the world, and it by far is the biggest. And lucky for us in the United States, we have huge amounts of freshwater in the Great Lakes. All right, here's Lake Michigan and Lake Huron, and then Lake Superior thrown in there. Some of the biggest lakes on the planet are the Great Lakes in the United States. Lake Victoria in Africa. All right, and then you have the Aral Sea, which is being depleted. We'll talk about that. And there's a couple others there, but just so you're aware, this makes the Great Lakes of the United States a tremendous commodity, something that we should preserve and protect because there's such huge freshwater supplies. Alright, I put these pictures in here because other surface freshwater is found in our rivers, which we don't seem to be taking care of. Alright, whether it be industry or municipal sources, we're literally just pouring pollutants and contaminants into our creeks and streams and rivers. All right, we're overusing our fertilizers and our pesticides. Sediment pollution is contributing to degradation of aquatic ecosystems. So we need to take a little bit better care of our rivers because that small percentage of freshwater is an important one. And to finish up here, wetlands make up another small component of the freshwater supply on the surface. This is a display of the states in the United States with the highest wetland losses. And if you look at Pennsylvania, we're at 56% wetland loss from the 1780s to current. And if you look here, Mid-Atlantic is really hard on its wetlands, along with California. All right, wetlands are an important ecosystem. They provide tremendous amounts of ecological services, and they're being lost at a tremendous rate. Why are our wetlands being lost? If you look here, mostly to development and to agriculture. So that's 77% is just to development and agriculture. Alright, but the amount of water we're using is steadily on an increase, whether it be municipal supply or industry or agriculture. All of our water use is on the rise, but the amount of water that's available to us is decreasing. To use water, we need it to be fresh and clean, and those sources that are fresh and clean are becoming more scarce. Okay, to wrap up this little mini section here on the distribution of water on Earth, all right, we have to be careful and aware of the unequal distribution of fresh water on Earth. Water is abundant, but usable water is rare. We need to take action today to make sure that future generations have the access and availability of water that we take for granted. And that means protecting and preserving freshwater supplies, taking a non-polluting approach to our actions, and also limiting our unnecessary use of this most precious resource. We live in changing times, and we really need to prepare ourselves for our continued way of life. And our way of life will obviously involve fresh, clean water.